Welcome to Math TV with Professor V. In this video, we're going to look at simplifying complex rational expressions. So what is a complex rational expression? The definition states that it's a rational expression in which the numerator and or denominator themselves contain rational expressions. So basically, it's whenever you see a fraction inside of a fraction, in the numerator or denominator of a fraction. That's a no-no. We consider that expression not completely simplified. You never want to leave your answers in that form. So there's two different methods that are commonly used for simplification of complex rational expressions. Either method will work on any problem, but sometimes depending on what sort of rational expression you're working with, one method's going to be easier than the other. So it's good to know both. That way you can use them appropriately in any circumstance. So first method, my favorite one, is when you multiply the entire expression by 1. This method makes use of a common strategy for fractions in which we rewrite fractions into a more desirable form by multiplying the fraction by 1. And in these problems, the 1 is written using the LCD, or the least common denominator, of all the minor denominators in the expression. So what the heck does that mean? I'll show you right now with an example. Use method number 1 to simplify. Okay, so we have 1 over 9 minus 1 over m squared over 1 over 3 plus 1 over m. The minor denominators are the denominators of the fractions within the fraction. So 9 is a minor denominator. M squared is a minor denominator. 3 is a minor denominator, and so is m. Okay? Our job is to figure out what is the LCD for all 4 of these denominators. Okay? So pretend like you're going to add them all together, but that's not what we're going to do. And notice the LCD is 9m squared. So since the LCD is 9m squared, and we're going to use method 1 here, what that means is I'm going to multiply the numerator by 9m squared and the denominator by 9m squared. And I'm allowed to do this because I'm multiplying by the same thing in the numerator and denominator. So I'm just multiplying the fraction by 1. Okay? Now, this next step, I'm really going to break it down for you to see how to simplify and multiply everything by this 9m squared. When you get more comfortable, you can start skipping steps and doing stuff in your head. Okay, so in the numerator, we have that 1 over 9 minus 1 over m squared. And then in the denominator, we have 1 over 3 plus 1 over m. And now I'm multiplying everything by 9m squared. So it distributes to both terms in the numerator. And if you need to remind yourself, go ahead and put that 9m squared over 1, okay, as you distribute it. 9m squared over 1. And then it also distributes to the terms in the denominator. So let's write it out here, 9m squared over 1, 9m squared over 1, okay? When you multiply the LCD to the numerator and denominator, it's always over 1, okay? Good. Now let's clean things up. So notice here in this first term, what can we cancel out? I can cancel out a 9. So I'm just left with now m squared, okay, for that first term, minus, and then now let's look at the second term in the numerator. What's going to cancel out? I can cancel out an m squared, right? So I just have a 9 left over. Perfect. Now let's move our attention to the denominator. What can we cancel out here? I can cancel out this 3. With the 9 in the numerator, now it's going to become just a 3. I still have that m squared though. So we've got 3m squared plus, and then last term down here, what's going to cancel? Just that m with one of the m's from the numerator. So we have 9m left over. All right, now here is where you need to check that you've done things correctly. There should be no fractions in the numerator or the denominator anymore. If there still are, then that means either you picked the wrong LCD or you didn't distribute and cancel correctly. So at this point right here, you should be fraction free. Now it's just a matter of cleaning things up. Okay, so yep, I'm super happy. There's no fractions in the numerator, no fractions in the denominator. I want to see if I can simplify and cancel. Before you even think about canceling, you got to factor the numerator and denominator completely. So look at the numerator, m squared minus 9. Do you recognize that? That's a difference of squares, so that will factor into m plus 3 times m minus 3. All right, very good. And then looking at the denominator, we have 3m squared plus 9m. There's just two terms, so what can I take out? What's the greatest common factor that I can take out from both those terms? That's right, it's a 3m. So I'm going to take out 3m, and now I'm just left with m plus 3. Lovely. Now I've fully factored the numerator, fully factored the denominator. If I see any common factors, I can cancel them out, and I sure do. I see m plus 3, so those are going to cancel. And then now, final answer, we're left with m minus 3 over 3m. Okay, you can't cancel any further. We don't normally put the parentheses around the m minus 3 like that when it's the only factor left over in the numerator. But keep in mind that m minus 3 stays together. It's like a little family. If there was an m minus 3 down here, then we could cancel. Okay, but you can't do anything weird like start canceling these m's. No, no, no. Don't break up the family. Don't be a homewrecker. That's an illegal math maneuver. So there we go. That's our final answer. All right, good. Let's look at another example, a little bit different. Here we have 2x plus 10 over x minus 3 over x squared minus 25 over x squared minus 9. So remember, when we find the LCD, we have to look at the minor denominators. What are the minor denominators? They're the denominators of each of the fractions from the numerator and denominator. And I can't quite find the LCD right now because x squared minus 9 isn't fully factored. So let's go ahead and do that first. I'm going to rewrite everything. I have 2x plus 10 over x minus 3. And then I have x squared minus 25. I'm just going to factor the denominators for now. Over x plus 3 times x minus 3. So now the minor denominators are here. X minus 3, x plus 3 times x minus 3. And what's the LCD for those two denominators? That's right, it's x plus 3 times x minus 3. So that's what I'm going to multiply by in the numerator and the denominator. And then one more here. And like I said, if you want to remind yourself each of these is over 1, okay, so you know how to cancel appropriately, go ahead and write that in. Okay, now let's look here at the numerator. When we distribute, x minus 3 will cancel out, but I still have that 2x plus 10 and x plus 3. So I'm going to write that out here, 2x plus 10, x plus 3. All right, now let's turn our attention to the denominator here. Both the x plus 3 and x minus 3's will cancel out. So all I have left is x squared minus 25. So that's going to go in the denominator. Okay, perfect. Now remember, you are not allowed to do any canceling until the numerator and denominator are both fully factored. So not everything is factored. Let's go ahead, take care of that. I'm going to turn my attention to this 2x plus 10. I can take a 2 out, right? So we have 2 times x plus 5 times x plus 3. And then what about this x squared minus 25? How do we factor that? It's a difference of squares, so that's going to factor into x plus 5 times x minus 5. All right, perfect. And then, I noticed I can cancel out this x plus 5. And then final answer, we're left with 2 times x plus 3 over x minus 5. You can stop there, or if you want to distribute the numerator, then it would be 2x plus 6 over x minus 5. It doesn't really matter in this case. Okay? Very good. So that's the first method. I like using that most of the time, but on occasions, another method is a little bit more advantageous to use. So let's look at what method 2 is. And you don't have to worry which one's method 1, which one's method 2. Just know that there's 2 ways to do it. Who cares what number it's called? Okay, method 2 is rewriting as division. So this method requires us to perform any addition or subtraction necessary to rewrite the expression as one single rational expression divided by another. We then complete the indicated division. So what does that mean? It means you're going to end up rewriting this fraction bar as the division sign, right? Because it means the same thing. And you're going to divide the numerator by the denominator. It's just that before you get to that step, you have to make sure that your numerator is one term and your denominator is one term. In this case, you know what? It is already. So we can just jump straight to that step. We kind of lucked out. So this is a nice example where this method might be easier than the first way we simplified. Okay, so we have here 2x plus 10 over x minus 3, and then I'm going to write instead divided by x squared minus 25 over x squared minus 9. Good? Okay. Then the next step, remember, when we're dividing two fractions, you want to change the division to multiplication and then flip the second fraction, multiply by the reciprocal. And while we're doing that, I'm going to factor everything too, okay? So instead of writing 2x plus 10 in the numerator, I'm going to write 2 times x plus 5 over x minus 3 times, and then we would have here x squared minus 9 in the numerator, but that's just x plus 3 times x minus 3. And then we also have x squared minus 25 in the denominator, but that's just x plus 5 times x minus 5. See how nice? Now everything is factored, and we can go ahead and start canceling any common factors if they're on opposite sides of the fraction. So notice here, I can cancel out this x plus 5. Even though they come from two different fractions, if one's in the top, one's in the bottom, they can cancel out. And the x minus 3 can cancel out. But that's it. Okay, that's it. This x plus 3, that's a little family. This x minus 5, that's a little family. So don't go in there and start doing something weird like canceling these x's. No, no, no. Then you'd be a home wrecker. You know, we can't have that. We cannot have that. So here, we've got the 2 left over, x plus 3 left over, and x minus 5 left over. So we have 2 times x plus 3 over x minus 5. And notice, same exact result as when we did this problem just a minute ago using the other method. Which way would you say is easier? I don't know, they were both probably the same, huh? Okay. Next example, this one's going to take a little more work. We can't jump straight to this step yet because you see how we have two terms in the numerator and we have two terms in the denominator, we have to add those together or subtract them first. Okay, so let me rewrite everything nice and spaced out. So we've got 1/9 minus 1 over m squared. So what's the common denominator just for these two terms? Not the whole expression, just in the numerator. What's the common denominator? It's just 9m squared, right? Okay, so I would need to, in order to get a common denominator, multiply this first fraction by m squared over m squared, and the second one by 9 over 9. Lovely. Now let's look at the denominator. We have 1/3 plus 1 over m. What's the common denominator just for these two terms down here? It's 3m, right? So we'll multiply this first fraction by m over m and the second one by 3 over 3. All right, so let's see what we have here. Remember, in the numerator, my common denominator ends up being 9m squared. And then I have 1 times m squared right here. So that's just going to give me m squared minus 1 times 9, which is 9. So we've got m squared minus 9 over 9m squared in the numerator. And then in the denominator, our common denominator was 3m. And then check it out, we've just got 1 times m, which is m, plus 1 times 3, which is just 3. Okay. Lovely. Now we're basically at the same step that we were at when we got problem A given to us. So here's one term. Yeah? And we can rewrite this fraction bar as division instead. So let's go ahead and do that. We have here m squared minus 9 over 9m squared divided by m plus 3 over 3m. And then from here, you're just going to rewrite the division as multiplication and then flip the second fraction. And at the same time, I'm going to factor everything. So m squared minus 9, that factors into m plus 3, m minus 3, 9m squared, can't do anything with that, times 3m over m plus 3. And I'm going to put some parentheses around the m plus 3 just to remind me that's a factor, that's a little family. If I do any canceling, they got to stay together. Anything we can cancel? This is always my favorite part. So satisfying. M plus 3. Bam, bam. 3m gone. With the 9m squared, it's going to become just 3m, right? Very good. So now we're left with m minus 3 over 3m. Okay. And you can check this is the same result that we got when we used the other method. Honestly, I like method 1 better for problems like this because I feel like it's a lot of extra work when you have to go ahead, get the common denominator first, and then divide and do all this flipping. Okay? This method is nicer when the numerator is already one term, one fraction, and the denominator is already one term, one fraction. If I see that I have a plus b like this over, and there's more stuff, then already I don't want to do this method. It's just going to get too messy. That's my personal taste, okay? You live your life. Just get them right. So here's another example. It says use either method to simplify. Honestly, I'm just going to do the first method because I'm noticing there's two fractions in the numerator, two fractions in the denominator. I don't want to deal with adding and subtracting them first and then dividing. Just sounds like a pain. I'd rather just be fraction free, hit everything with the LCD from the get-go. Now, in order to identify the LCD, I have to factor all the denominators. So let's go ahead and do that first. So we've got 1 over, let's factor x squared plus 3x minus 4. So how does that factor? Very good. X plus 4 times x minus 1. Ooh. If you need a review on factoring, I'll link some videos here and in the description box. Plus, then we have 3 over x minus 1. If you want to put parentheses around it, cool. And then in the denominator, 4 over x plus 4. That's done. Minus 5 over, now we have to factor again, x squared plus 3x minus 4. But we just factored it, so no big deal. X plus 4, x minus 1. Okay, so you guys tell me, what is the LCD of all the minor denominators? What are the minor denominators? We got 4 of them. Here, 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 and here. So the LCD for these 4 guys is, yep, x plus 4 times x minus 1. So I'm going to multiply everybody in the numerator by x plus 4 times x minus 1, and everyone in the denominator by the same thing. If you want to remind yourself that each of these is over 1, go for it. Okay, how are we doing so far? Now, at this step, remember, you're going to have to distribute as you multiply out the LCD to the numerator and denominator. When you get more comfortable, you could probably distribute and cancel in your head. I'm assuming you're not there yet, so I'm going to write the LCD next to each of the terms and go through this step by step with you, okay? So we have 1 over x plus 4 times x minus 1, and then that's going to get multiplied by x plus 4 times x minus 1, plus 3 over x minus 1. That gets multiplied by x plus 4 times x minus 1. Let's put those parentheses. And then in the denominator, I have 4 over x plus 4. That gets multiplied by x plus 4 times x minus 1. Remember, that LCD always goes in the numerators when you're distributing. Minus 5 over x plus 4 times x minus 1. And that's going to get multiplied by x plus 4 times x minus 1. Okay, now my favorite part, cancel party time. So bam, bam, those completely cancel out, x plus 4 and x minus 1. So all that we're going to be left with for that first term in the numerator is a 1. Plus, let's look at the next term. X minus 1 cancels out. So I have 3 times x plus 4. Good, good, good. Now let's look at the denominator. X plus 4 cancels out. So we have 4 times x minus 1 left, minus x plus 4 and x minus 1 both cancel out. We just have 5. Okay, how are we doing so far? The worst is over, I promise. Now, no canceling can occur right now because the numerator and denominators are not fully factored. It's only cancel time when you have a sea of parentheses like this, you know? Then you can start canceling. But as soon as you have like parentheses, parentheses, plus something, it's not cancel time. So don't throw that cancel party prematurely. Let's distribute, clean up, and then see if maybe we can factor and simplify further. So here we go. We've got 1 plus 3x plus 12 in the numerator over 4x minus 4 minus 5. So let's see, in the numerator, 1 plus 12, that's 13. So we have 3x plus 13. And then in the denominator, 4x minus 9. 3x plus 13, I can't factor that any further, no. 4x minus 9, I can't factor that any further. When you can't factor any further, technically, you know, think of them as a little group, a little family in parentheses. We don't write our answers that way, but that's what's going on. So if thinking that way helps you from doing any illegal canceling, add them in for now. But yeah, we're done. Do you love it? It takes practice. Then it'll be more fun. Okay. I got another example for you. This one's a little more spicy. Complex rational expressions may also appear in a slightly disguised form through the use of negative exponents. In this case, we must first carefully rewrite the expressions using positive exponents and then proceed as before. And as a note of caution, I want you guys to understand how negative exponents work. So if you have 3x to the negative first, that negative 1 exponent is only applied to the x because it's just touching the x, that's it. So you would rewrite this as 3 over x. But if you had 3x in parentheses like this raised to the negative first, then you would rewrite that as 1 over 3x, because the parentheses means that negative 1 exponent applies to both the 3 and the x. Do you see the difference? Okay, good. So we're going to have to do that now in the next example where we simplify. We have a to the negative first plus b to the negative first over a squared minus b squared over ab. So first things first, let's rewrite a to the negative first and b to the negative first as 1 over a plus 1 over b. Good? Okay, and then in the denominator we have a squared minus b squared over ab. Now I'm going to use method 1 first to simplify. So in that case, we're going to multiply by the LCD of all the minor denominators. So look here at the denominators. We've got an a b, and an ab. So what's the LCD for those 3 denominators? That's right, it's ab. So that's what I'm going to multiply everything by in this expression. I'm just going to already distribute it like this. ab, ab, ab. Okay? And then now we can cancel and clean up. So let's see here. In this first term, a cancels out. So I'm just left with b. Cool. Plus, and then let's look over here. B is going to cancel out, so we're just left with a. And then now, please turn your attention to the denominator. And I notice, oh, AB cancels out, so I just have a squared minus b squared. Okay, perfect. Now let's see here. Are we on the right track? Do we have any fractions left in the numerator or denominator? No, we don't. So it looks like things are headed in the right direction. Now from here, I want to see if I can factor the numerator and denominator more and then maybe simplify after canceling. Numerator is done. B plus a, Denominator, a squared minus b squared. You can factor that into a plus b times a minus b. And keep in mind, since addition is commutative, adding, the order doesn't matter. A plus b and b plus a are the same factors. These cancel out. Don't forget though, you still have that 1, right, in the numerator when everything cancels out from upstairs. So your final answer is going to be 1 over a minus b. Okay, how was that? Not the worst one we've done, huh? I think the previous example was a little more tricky. Now, how about trying this with method 2? Just so you can compare. So let's try it with method 2. And originally, I'm just going to jump to after we rewrote this with the negative exponents in the denominator. Okay, so method 2, if we have 1 over a plus 1 over b over a squared minus b squared over ab. So method 2 basically says if there's addition or subtraction in the numerator or denominator, you do that first, and then you rewrite this division, this fraction bar as the division sign after you do that. Okay, so let's look here at the numerator. If I want to add these two terms together, what would my common denominator be? It would be AB, right? So I'm going to multiply this first term here by B over B, and the second one by A over A. Very good. And then the denominator, I don't have to do anything with, because you see how it's already one fraction, it's one term. So in this method, you just leave that alone. It's happy, minding its own business over there. And so in the numerator, I'm going to have b times 1, so that's just b, that's from right here, plus a times 1, which is just a, over ab. And then this is over a squared minus b squared over ab. Very good. Now we rewrite the fraction bar as division. So in the next step, I'm going to have b plus a over ab divided by a squared minus b squared over ab. Good. And then next thing we need to do, change this to multiplication, flip the second fraction, leave the first one alone. So it's b plus a over ab times, and then we have ab over, are you guys cool if I factor that a squared minus b squared, a plus b, a minus b? Yeah? Lovely. And then right away, I can cancel the a plus b with b plus a, and then I can also cancel ab with ab. So we're all done now. Since everything canceled in the numerator, I have a 1. Don't forget that. There's always a 1 left over when everything cancels somewhere. And then a minus b in the denominator. Very good. Very good. When you get comfortable, you might notice at this step right here, when you get semi-professional, you see how these denominators were the same? You can just cancel them because they end up canceling right here at this step if you want to skip all this. I'm cool with that. Maybe your teacher won't be though, so run it by them first. Okay, last example. I want you guys to pause the video before we keep going and see if you can rewrite this expression without negative exponents first, okay? And then check in before you try to clean it up. So pause the video and then check back. Okay, so this one's a little bit tricky. Notice that this a and this -3 are not in parentheses, so they're not going to get flipped to the denominator since this -1 exponent does not apply to them. So the first term, we're going to rewrite it as a over a plus 2. Do you see that? Minus 3 over a minus 3. And then in the denominator, we're going to have again a over a plus 2 minus, and then if I put a minus 3 in the denominator, I still have a 1 left over in that numerator. Lovely. I'm totally going to go with method 1 here. I don't feel like sitting there and doing this subtraction and then dividing and all that nonsense. Let's just cut to the chase. What is the LCD for all the minor denominators? So the LCD for a plus 2, a minus 3, and we got the same stuff going on downstairs. That's just going to be a plus 2 times a minus 3. So let's multiply everything in the numerator and denominator by that. And I'm just going to go ahead and write that LCD next to each term. Okay. I'm putting the over 1 just in case it's helpful. So you remember when we're canceling where everything is. And there's 4 terms, so everything's going to get multiplied by that LCD. A plus 2, a minus 3. And like I said, when you get more advanced, you won't have to write it out next to each term. You'll be able to do it in your head. So it feels tedious right now, but with practice, you'll get a lot more proficient at it and slick. Okay. Are we ready to cancel? I think so. I think so. So let's look at this first term here. What's going to cancel? The a plus 2. So we're just left with a times a minus 3. And then we have minus, okay, bring down that minus sign. And then what's left over here? Let's see. A minus 3 cancels, so I have 3 times a plus 2. Good. Now let's look at the denominator here. What's going to cancel? A plus 2. So I'm just left with now a times a minus 3. Bring down that subtraction sign, so we've got minus. And then last term, a minus 3 is going to cancel. And I just have a plus 2. But please put parentheses on the a plus 2 because that minus sign needs to distribute. Okay, this is a dangerous place for a lot of students. They get too excited and they start wanting to cancel. Oops. They start wanting to cancel out these terms that they see. But no. You're throwing your cancel party prematurely. The numerator is not completely factored. You see how we still see subtraction? Neither is the denominator. You can only cancel when everything is just a sea of parentheses like this. The minute there's a minus something, it's not cancel time. Everything's not fully factored. So you gotta have some self-control. What does that mean for us? That means we're gonna distribute. Oh yes, and then clean up and then see maybe after factoring completely, can we cancel? I know. Okay, so we've got a squared minus 3a minus 3a minus 6. Yeah? Good. Over, and then same thing, distribute in the denominator. So we've got a squared minus 3a minus a minus 2. And then let's combine our like terms. So we've got a squared minus 6a minus 6 in the numerator. And then a squared minus 4a minus 2 in the denominator. Okay, does the numerator factor any further? No, there's no two numbers that multiply to -6 and add to -6. So that's done. If you want to think of it, it's basically a factor like this, right? It's prime. Does the denominator factor? Can you think of two numbers that multiply to -2 and add to -4? Me neither. So that's a factor basically like that. Boop. They're each prime. So that means there's no more canceling that can happen. This is your final answer. Don't do some bizarre stuff like this. The math police are going to come get you. Illegal. So you just box it to stop yourself, right, from getting carried away, and that's your final answer right there. Okay, so that's it. I know it's hard when you're first learning the rules because you have to keep reminding yourself what you are and aren't allowed to do. But after a while, you'll just become more fluent and you won't have to stop and think so much. It's like when you learn a foreign language. You have to always remember your conjugation rules and this and that. But then once you're fluent, you don't stop and think so much. Same thing with math. You'll become fluent. You just got to keep practicing. All right, stay tuned. Give this video a thumbs up if you found it helpful. I'll go over more with rational expressions soon.